This video covers topic 19.5 over multiplying radicals. Our bell work is to remember how we simplified radicals when adding or subtracting. When I look at the first radical, the square root of 6 cannot be simplified. The square root of 3 cannot be simplified. As previously stated, the square root of 6 cannot be simplified, but the square root of 48 can. So I need to simplify this first before I add, because if I don't, then I'll be adding things that I don't need to add or have to come back and add later. So the square root of 48 is 4 and 12. 4 can be broken up into 2 and 2. 12 can be broken up into 2 and 6. 6 can be broken up into 2 and 3. So I have 2, 2, 2, 2, and 3. So 2 pairs of 2 are going to go outside the square root. 2 times 2 is 4, and then a square root of 3 stays inside the square root. And then 8 times 4 are both outside of the square root, so that would be 32 square roots of 3. So I will replace this with 32 square roots of 3. So remember, when we combine, we add or subtract our like terms. So square roots of 6, square roots of 6. I have 3 minus 2 square roots of 6. So 3 minus 2 is 1 square root of 6. And then square roots of 3, I have 6 square roots of 3 and 32 square roots of 3. So 6 plus 32 is 38 square roots of 3. So when we add or subtract like terms, the first thing we have to do is simplify like we did on the right side with the square root of 48. And then you add or subtract, combine like terms, so things that have the exact same square roots. So today, these notes are talking about multiplying radicals. In order to multiply, our steps are listed here. You multiply the outside numbers and keep them outside, multiply the inside numbers and keep them inside, and then simplify the radical if possible. So problem 1 has been done for us. 5 and 6 are both under the radical, inside the square root, under the house, however you want to say it. So we multiply. 5 times 6 is 30. So that stays under the square root, inside with inside. Now 30 is 3 and 10. 10 is 2 and 5. I don't have any pairs, so this cannot be simplified further, and therefore is my final answer. So let's try problem 2. Problem 2 is 3 times 8. 3 times 8 is the square root of 24, because 3 times 8 is 24. Now 24 can be broken up into 4 and 6. 4 is 2 and 2, so we at least have one pair. 6 is 2 and 3. So we have 2, 2, 2, 3. So a set of 2's can come outside of the house. And then 2 times 3, 6 stays inside the square root. So 2 square roots of 6 would be the most simplified form of that. Okay, so problem 3 has been done for us. As our step said, outside with outside. So 5 times 6 is rewritten, both of them on the outside. 7 times 2, both of them on the inside. So this step is a simple rewriting that can help you see very easily what needs to happen. So 5 and 6 are both outside, 7 and 2 are both inside. Outside, 5 times 6 is the square root of 30. Inside, 7 times 2 is the square root of 14. 14 is 2 times 7. There are no pairs. This cannot be simplified. So we simply rewrite it as 30 square roots of 14. Problem 4 has also been done for us. Same first step. Negative 2 and 5 are both outside, so we multiply those together. 6 and 8, both outside, so we multiply those together. So negative 2 times 5 is negative 10. 6 times 8 is 48. Now 48 can be simplified. 48 breaks up into 4 and 12. 4 is 2 and 2. 12 is 2 and 6. 6 is 2 and 3. So we have 2, 2, 2, 2, 3. 2 and 2 can go outside to be 4. 3 stays on the inside. And then we had negative 10 from the very front that goes back in front. So front with front, negative 10 times 4 is negative 40 square roots of 3. And again, just to show you very quickly, you can plug this in. So negative 2 square roots of 6 times 5 square roots of 8. Is that the same as negative 40 square roots of 3? Same ugly decimal. Okay, so the only big difference here is you're doing outside with outside, inside with inside, then simplify if you can. And when we simplify, we do the same thing where we simplify and then take the front into effect. Okay. So outside with outside, negative 6 times negative 8 is going to go outside, inside with inside, 2 times 2. So negative 6 times negative 8 is a positive 48. Inside 2 times 2 is 4. Now we know the square root of 4 is 2. And you could also say there's a pair here, so I'm going to move it outside. However you see it. 48 times 2 is 96, and that's my answer. So there are some where you could very quickly plug this into the calculator. Negative 6 square roots of 2 and negative 8 square roots of 2 is 96. So there are some that you can very quickly plug into the calculator. Problem 6 is one that would be very easy to plug into the calculator. The square root of 5 squared is going to be 5. And I've listed out the reason why. The square root of 5 squared is the square root of 5 times the square root of 5. Both of them are on the inside, so we multiply them. Both stay under the square root. Now remember, to get out of the square root, you need a pair, and I have a pair of 5s. So anytime you have the square root of something squared, it will cancel or get rid of the squared. Squared and square roots get rid of each other. So problem 7 you could plug into the calculator. If you don't remember how to plug into the calculator, you can write it out. So in front, 3 times 3, in the square root, 2 times 2. I have a pair of 2's under the square root, so they can come outside. So if you don't have a calculator, if you have like a phone calculator, then all you have to do is 3 times 3 times 2. 3 times 3 is 9, 9 times 2 is 18. Or if you have one of the calculators, or if you're still in class and you can use a class set, you can do 3 square roots of 2 squared in the calculator exactly like you see it and get the answer very quickly. However, remember, if you have a decimal, like 1, 2, 3, and 4 would all be decimals. If you get a decimal out of the calculator, then you have to simplify by hand, following these steps listed here.